Hello and welcome to a tidy calculation system, or R is for everyone, not just for numbers fans. Here we get ambitious. We presume you know a bit about using R-Instat, perhaps from the first two tutorials, though this video isn't dependent on them. We introduce the calculator. This is in the Prepare menu and is a very powerful tool. It's not quite as easy to use as the dialogues you've seen so far, but it provides immense flexibility. We want to make the case that R with R-Instat can help with the teaching and learning of statistics and data science at many levels, even starting at school age. For educators, our proposal is that adding R-Instat will improve the accessibility for many students who find R by itself too tricky or even impossible. We hope that individuals can use this video to reflect on how they could use R and R-Instat to further their work and in training courses. There are many excellent books that use R, but they all start by assuming you must first learn the R programming language. For example, in the Introduction to Data Science book, the first 6 chapters are on R, while data visualization in R directs users to a set of resources to first learn R. We are huge supporters of R. It's an excellent and powerful language. However, it has a steep learning curve, and this makes an unnecessarily high barrier for some people. We hope that R-Instat can ease this. Here we consider 3 potential users of R for their statistics or data science courses. Christina is our R fan. She's keen on computer science. She attended the introductory R course and found it easy. She liked Python too. Then she used R in the statistics course, through RStudio. She found all of this fine and enjoyable. Talia is R OK. She quite likes numbers, but is more interested in biology and language. She was able to cope with the introductory course for R, but throughout the statistics course, she kept needing to be reminded of the appropriate R commands. It was a distraction from the statistics. At the end, her R had improved, but she didn't learn as much statistics as she would have liked. Thomas is R shy. He would not dream of going on a programming course. He knows he will suffer in the quantitative parts of his coursework and is dreading the data science. He can cope with Excel but doesn't even like that much. Our fan is registered for a degree in statistics and enjoys specialist courses. For ROK and R Shy, statistics is a necessary service course for their main subjects. R-Instat is designed to make R sufficiently easy to use that students can concentrate on the data problems as they learn statistics. Therefore, an introductory R course is no longer needed. Instead, R-Instat will be taught in the first course alongside statistics. Ugh, what's the point? It's so easy and efficient to learn R. Point-and-click software can't possibly get close to the power and flexibility of R commands. Phew, what a relief to have a new starting point. I hope I will finally be able to focus on the statistics. I'm not yet convinced. It'll probably still be impossible. R-Instat has been built with a range of users in mind, so there are lots of choices within it. You can avoid R commands completely, making it easy to use. You can learn about R commands as you go along without needing to write them yourself, so you start to move towards R. And you can even use your own or other people's code via the script window, giving people like R fan the flexibility and efficiency that they crave. In halfway dialogues like the calculator, the keys build our expressions without users needing to code. In this video, we want to show the flexibility and power of R-Instat. Some of this may be a stretch for R Shy, but we hope he will see how far he can reach and gain an understanding of what is possible at the same time, even if he sometimes needs to request help from an R fan. Start by making a new data frame. We want 100 rows, but we're happy with the default 2 columns. Press OK. Here's our data frame. Now go to the Prepare menu and open the calculator. We hope that your first impression is that it looks simple, a bit like a calculator on a mobile phone, and we can use it that way. Type in 3 plus 5, then press the try key. It shows it as 8. The up arrow is for powers, so we press clear and then type 3 to the power 5 and try. This gives 243, which is 3 times 3 times 3 times 3 times 3. What you type into the expression field is essentially an R command. That's why we call the calculator a halfway dialog. The usual dialogs produce R commands for you, so you don't have to type them. When you type, there is a risk that you will type wrongly, so use the keypad as much as possible. Though mistakes don't really matter, as they'll just give an error message rather than the result. Let's try making one now. Add a closing bracket at the end of your calculation and click Try. Now we see there's a problem. Click on the 3 dots for more information. It tells you there's an unexpected bracket. When we take the bracket away, the calculation works again. But this is more than just a number calculator. It's a column calculator. Clear the expression box, then add the variable x1 and multiply it by 5 to get the 5 times table. Save the results to x2. Our second column now contains the 5 times table from 1 to 100. Let's try that again with powers. Use the toolbar to reopen the calculator. Then change the expression to use the up arrow caret for powers. Type power 5 into the Save Results box. Let's check. It's always good to examine the results, and being able to look at data quickly is a useful skill. So 2 to the power 5 is given as 32. Then we have the 243 from earlier, and 10 to the power 5 is 100,000, as we would expect. Scrolling to the bottom, we can look at some of the bigger numbers. Let's expand the column to do this. We can see that 100 to the power 5 has 10 zeros. Another way to check would be to reopen the dialog and calculate one of the values. Enter 97 to the power 5 into the expression row and use the try button. Oh, that's curious. It's gone into scientific notation, but we see the numbers are the same, so we feel confident about the result. Let's explore the power of the calculator a bit more. It has extra keyboards that you access from the drop-down menu. Selecting one opens an additional keyboard to the right of the basic keyboard, which always remains available. The Maths keyboard shows it can also be a scientific calculator. We use it to add a square root column. Click on square root, add the variable x1, try, and we'll call the column square root. Then click OK. That seems to have worked. At least it shows that the square root of 100 is 10, which we know. How are you doing, Thomas? You look a little bit green. Are you still with us? Well, you said that using R-Instat would be easy and fun, but I feel like you've tricked me into writing R commands. That being said, I actually think I am keeping up for now. Well, I'm glad to hear that. For now, I want to continue using this halfway dialog way of using R-Instat. Though later I will show you how to avoid using these commands and even the calculator completely. We look at a new keyboard, the integer keyboard. Here we'll introduce something that will be new to many of you, or at least partly new. Go to the integer keyboard and try the divisors key. Add x1 as the variable, and save the results to a column called divisors. Let's go back to the top of our dataset and make this column a bit wider. We've marked rows 11 and 12 because they're quite different. You can see that 11 only has 1 as a divisor, whereas 2, 3, 4 and 6 all divide into 12. We'll see below that 11 is an example of a prime number, while 12 is the smallest abundant number. Let's look quickly at prime numbers and abundant numbers. First, primes. Back in the calculator, clear the expression box and click on the primes key. Try, and save to a column called primes. Then click OK. From a teaching point of view, we're doing something different here. In many courses, the theory comes first, then you get the examples. That suits some students. But here we're doing the example first and then explaining what we mean by divisors, primes, and abundant numbers. This can be helpful for those students who learn better when they can see an example in front of them and therefore grasp what's being discussed. Notice that the 25th prime number is 97. So a quarter of the numbers less than 100 are primes. Meanwhile, if we scroll down to the bottom, we can see that 541 is the 100th prime. So up to 100, 1 in 5 numbers are prime. But we don't know what happens after that. Looking back at the divisors column, we see that prime numbers only have 1 as a divisor. This is their distinguishing feature. Prime numbers are numbers that can only be divided by 1, or themselves, of course. Now, abundant numbers. These numbers are sort of the opposite of primes. They have lots of divisors. Clear the expression box, choose the abundant key, try, and call the column abundant. Then click OK. Abundant numbers don't just have lots of divisors. Their divisors add up to more than the number. The first abundant number is 12. As we can see from our divisors column, the divisors are 1, 2, 3, 4 and 6, which adds up to 16. Fan, you're looking a bit puzzled. I'm just wondering, what's the opposite of an abundant number, and can we get some? I don't see a button for that. The opposite of an abundant number is a deficient number. Deficient numbers like 4 are where the divisors, here 1 and 2, add up to less than a number. We haven't chosen to include a deficient key in R-Instat, but it is in the same R package as abundant numbers, so you could use the key for abundant and then type deficient in the place of abundant. As before, we then try it to check that it's working and save the new column. We'll call it deficient. Oh, Shy, you're looking very poorly now. I don't blame you. Why don't you go outside for a few minutes and get a drink of water? You won't like this, and really you don't need to see the bits we're going to do now. How would I know to do that to generate deficient numbers? Well, that's why I suggested Thomas might like to leave for now. It takes some interest and curiosity in R packages, which I think you have. In this halfway dialogue, we have R help as well as R-Instat help. And it's in the R help that you can find more information about the packages behind these keyboards. Click on the down arrow on the R help button. This will show all the packages that are used in this keyboard. It's clear from the abundant expression that the package used here is ZSEC. Click on ZSEC to move to the user guide for that package. From here, scroll down to find deficient. You can click on it for more information. It's then easy to return to the index And you could explore the other commands that are available here. For example, how could we have omitted evil and odious numbers? They have such good names. Christina, you can now explore any of these with just a small tweak to the command. This is an easy way for more adventurous R-Instat users to access the full breadth and flexibility of this curated collection of R packages. This is a good moment to briefly delve into R and R-Instat. R has over 18,000 different packages. In R-Instat, we've chosen the packages we think are best for each of the operations. Within each package, we've chosen to include buttons for the most used elements, but the packages are often much bigger. One benefit of the halfway dialogues is that you can easily change the expression to access more. And if you need to tweak items further, you have the script window, which gives you the freedom to use code. Let's get back to our calculator. Oh, Talia, do you have a question? Well, first of all, I feel like there's plenty of power in the calculator with its 500 keys, without needing keys that aren't even there. Is there help on these too? You're right, there are a lot of buttons in the calculator, but there are also tooltips. So if you're not sure what something does, simply hover over it and it'll give you an explanation. Here's divisors, which we looked at earlier. And here's Fibonacci. Yes, I noticed the Fibonacci key. Don't those numbers have something to do with the golden ratio? I don't really know what that is. Also, there's a Fibonacci 2 key. Why are there 2 keys for the same thing? Good question. Yes, the golden ratio is about 1.618. And like pi, it just seems to come up all over the place. In nature, art, architecture, music, physics, and more. You can see this description from Maths is Fun, where you can find lots more information and even some simulations of the golden ratio. And you're right, there is a relationship between the Fibonacci sequence and the golden ratio. The ratio between successive Fibonacci numbers is very close to 1.18, and it gets closer and closer as the pairs of numbers get bigger. We can use the calculator to explore this more. Try the Fibonacci key with the numbers in x1. The try button seems to work. Type in Fibonacci and click OK. Next, let's look at some ratios between successive values. Reopen the calculator and clear it. We're going to use it as an ordinary calculator again. Choose some successive values and check their ratios by typing them into the expression box and using the try button. 13 divided by 8 is 1.625. 21 divided by 13 is 1.615. And if we go down a bit, we can see that 610 divided by 377 is 1.618. This is fine for a few quick checks, but we have a column calculator. So instead of risking typing errors with larger values, let's look at the whole set of ratios. Clear the expression box again and use the drop-down menu to open the Transform keyboard. Press the lag key and add the Fibonacci variable. Try the expression. Type Fibonacci 1 into the Save Results box. Click OK. Now we have 2 Fibonacci columns, which are offset by 1, so getting the ratios will be easy. We simply divide Fibonacci by Fibonacci 1. Go back to the calculator and clear the expression box again. Now add Fibonacci and divide it by Fibonacci 1. Try the expression and then type golden into the Save Results box. Now we have a whole column of ratios from 1 to 100. Let's digress to quickly show this as a graph. Go to the Describe menu, Graphs, Line Plot. Add golden as the single variable and x1 as the x variable. Add points and click OK. Maximize for a good view of the graph. Now, as you become a statistician, we like to think of you as also becoming a data detective. What do you notice about this graph that's curious? One oddity is what isn't there. It doesn't seem to go to 100. Let's look at the data. From the Fibonacci column, you see that the numbers are getting large, really large. Row 46 is already more than 1 billion. This is getting to the limit of integers, whole numbers in R, so it can't calculate larger ones. I quite like them being integers though. They're on the integer keyboard after all. The Fibonacci 2 key is a solution to this. It's from a different R package and it saves them in a way that allows for larger numbers. Let's give it a try and see if we can get to 100. Save this column as Fibonacci 2. Here's our new Fibonacci row, and it does go all the way down to 100. Wow, row 100 is big. I've heard that a googol is a really big number. Is that a googol? Or maybe even bigger? It is big, but shockingly, it isn't even close to a googol. If all the numbers after the 2 were zeros, then this would have 20 zeros, whereas a googol would have 100 zeros. This is still more than the number of grains of sand on Earth though, including the Sahara Desert, so it is very big. Shy, I can't believe it, but are you getting interested in numbers? Ha ha. No, that was definitely a mistake. I'll be quiet again from now on. Now, Shy, as promised, you can often avoid this halfway calculator dialogue, at least until you're comfortable with the simple use of R-Instat. For example, making the square root column can be easily achieved using the transform dialog instead of the calculator. Go to Prepare, Column Numeric, Transform. Make sure you're on the non-negative tab. Enter x1 as the column to transform, and type square root into the new column name to overwrite the existing column. Here's our new column, and you can see the result is the same, but now R-Instat constructed the R command rather than you. That's a safer and maybe simpler way to use R-Instat. Most of the R-Instat dialogues are safe. The calculator is an anomaly. Okay, you have a question? Well, you call this video a tidy calculation system. Why is it tidy? I'm pleased that you noticed. I claim that R is a messy or quirky statistical language, rather like English is a pretty messy spoken language. One reason R is so wonderful is that thousands of people have contributed different packages to enhance R, so it's a statistical language that can do many things. But the different packages are often used in slightly different ways. That's one reason you kept finding new things with R in your previous courses. The R-Instat calculator tidies the messiness. The calculator alone uses over 20 R packages, but you don't have to worry about any of that. You just press the appropriate key and the R command is generated. We like to think that that's tidy, or at least tidier. Finally, an objective of this video and practice is for you to plan how you might use R-Instat in the future. Okay, you go first. I'm happy to start with the R-Instat approach. I think it will help me with data and with statistics. I can learn R later if I need to. In the original R courses, I found I kept learning more about R than about data or statistics. So this feels pretty refreshing. I mean, we worked on real data. What about you, R fan? I like programming. You say R is a quirky language, and I think that's fun. I will still use RStudio for my work. But I do like that R-Instat makes it easier for me to collaborate with people who don't understand when I talk R. And finally, what about you, R-Shy? I was okay with the first 2 R-Instat tutorials, but this was pretty tricky at times. I think I'll stick with the simpler dialogues, and I'm still not really interested in programming. When it's needed, maybe I can get our fan to do those bits for me? And the real question is to all of you. Where are you on this spectrum? Have a think. Are you more of a fan, okay, or shy of R? If you teach, then it's likely that you're a fan in your own capabilities. But how does your class divide up? If your students are also fans, then the R language and programming should come first. You don't need R-Instat. RStudio is great. But many non-specialists also take courses in statistics and data science, and they may be more like R-OK or R-Shy. In that case, consider R-Instat first. It may be a gateway to RStudio, or it might be all that they need. We hope that we've shown that there's something for everybody here. For the Christinas of the world, these dialogues help users to access more of the full power of R. For the Talias, they stir their curiosity, and we use the calculator in more videos to extend this idea. And Thomas still seems able to cope, though perhaps only just.